Stream, what's up? So today we have switched the language that we are going to use to build Standup Fight B from Node.js to Golang. And how did I do that? Very simple. As you can see, I'm using Google Anti-Gravity, and I just asked Anti-Gravity to do this for me. I just had to interfere a little bit in between, and now as you can see, I have my Golang API up and running, right? So there is a jokes endpoint that's running. There is no response because we have to build that out. And as you can see from our stream plan, we are going to do that today. We're going to go through the low level backend design. Then we're going to design the schema of the app. We will choose the DB. Right now, I am relying on MongoDB by default. Then we are going to go through the DB design. We're going to talk about trade-offs. Then we are going to go over the matchmaking algorithm, and we will read about the data structures and algorithms utilized in matchmaking algorithms. We'll read about some high-level components for the matchmaking algorithm, the WebSocket server setup, what sort of configuration it's going to need. We're going to do some trade-off analysis uh, for whether or not we should keep the WebSocket server in the same web app or should we keep it outside. What sort of trade-offs will be there. We will go over the build. We will build the APIs and plug in the components. We will do this. We will do all of these steps for the joke delivery algorithm, where we will need to, I think, utilize some event streaming technologies. We'll read about that. We'll do trade-off analysis there as well. Here you can go over the basic requirements of matchmaking algorithms. We need to match players based on their ratings. So more humorous people pair with more humorous people, and learners ramp up on their track. Ensure that only one waiting room is active at all times. So that's a DB constraint. For the joke delivery algorithm, we will reach all the users who are in feed. There is a battle of 1 minute. We want to finalize the scores, and we need to ensure that all jokes get the same weight because the battle is going to be 1 minute in length, and the first joke gets more time in the system to get scored and evaluated for the final result of the battle. So we have these requirements. It's going to be a fun build. Stay tuned. Now, let me just quickly go over what anti-gravity has done for us, right? So I went into the prompt, asked anti-gravity, gave it let me just pull up the history. Simple. Okay, here it is. So as you can see, if I can pull up the zero file changes, three artifacts. Okay, so this is logo artifacts. Okay, so tasks. Yep. So those artifacts, because I had to restart anti-gravity. So now those implementing database connections, tasks. Yeah. So, all right, you can see, I think still see the task list. I actually want to show you the implementation plan. Okay, it doesn't have that. So, we don't need that. So basically, I gave it the path to the root directory of the Node.js implementation of Standup Fight B. It just went through the existing Node.js application, created an implementation plan for Go migration. It went ahead, initialized Go modules, created project structure. It created two packages, one internal and one command, which has the main server. Then basically created the database connections file and everything. And as you can see, as of now, my DB, my web app is up, running on port 7000, and we can actually access the APIs, right? So that is all for what anti-gravity has done. But let me just quickly give you a deep dive into the structure because we are not utilizing any sort of web framework, right? So let me just do a side-by-side comparison of the Go file and the Node.js file, right? So we have our Go file, which is server.ts here. So as you can see, let's just quickly do a side-by-side analysis. All right, here we go. So as you can see, uh, connect DB here, right? And init env, we discussed this yesterday during our no boilerplate, no dependency scaffold of the Node app. So no init env is here, but there is connect DB. As you can see, it tries to get from the environment, which is injected using the CLI command. And we start the server here simply, and same is written here. We start the server. Where is the server? Server is actually located as an internal package, right? So we go ahead and check out the server. So as you can see, there is an internal package, and inside internal there is a server folder, and it has package server. So that is some of the nuances of Go that you have. The directory you're in, that will be the package name, right? So now what server does here, it just uses the standard Go HTTP module, registers routes. Now if I jump, you can see it just doesn't use any Go module for routing. Simply the server multiplexer uses a path and a handler and just returns the route back to our server start function, which just starts it on the given port, right? So at this point, what do we need? There's routers are handled, and now we have controllers and get chokes. So get chokes is just a function, exported function in the jokes controller. What it does is it tries to access the jokes collection as of now, and just returns the results that it gets from the database, right? Now, if you check out the structure of both Go and Node applications, you'll see that the command API folder has the main file, which is comparable to our server. Then there is an internal package, which has our controllers, files related to database connections, and then we have our models. So you might want to know, you might want to, you might ask like, how are we querying the database, right? So database client is exposed using this internal, and I think it's a MongoDB driver for Go. Yep. So yes, that is correct, and we are using the direct URI. We are not reading it from environment because we are not injecting it. So today I'm going to build that out, and now we have models. So it has just used the basic structuring that I did yesterday, but we are going to revamp this because we want to choose the database first. Then we are going to do some more uh, deep schema design because we want support for views. We want support for uh, higher basically higher range of uh, numbers for scoring, right? And now we have our Go modules, which is equivalent to a package JSON and a Go sum. So that's it for this Node.js to code translation by anti-gravity. I am going to continue and build the low-level design, extend this low-level design, and include more concrete functionality so that we don't just get an array of empty jokes because we want this to work. All right, till that time, stay tuned for more stuff.